Hello everyone, this is Vikram and welcome to my channel. In this video, we'll see how to design our own version of kube-monkey in Python and understand how to Dockerize this application and deploy to Kubernetes environment. We'll focus majorly on understanding the Kubernetes REST API in order to create kube-monkey in Python. And these are the various topics that we are going to cover. We'll understand what is chaos engineering and kube-monkey, how to make API calls from Kubernetes pods to the Kubernetes API server, how to frame that API call, what are the parameters required, what are the authentications required. So we'll cover everything in detail. We'll also use Python's request module because we'll be making API calls in Python. So we'll use the request library. Of course, if you have any other library in Python, you can also use it. And we'll also understand how to parse JSON output in Python, because whenever we make an API call to the Kubernetes API server, we are going to get the response in JSON. So we'll understand how to parse this response. We'll understand what are service accounts and role-based access control, so that our kube-monkey pod that we are going to create will have necessary authentications, permissions to basically make any API call. Since we are going to write our complete application in Python, we'll also see how to Dockerize the Python application and understand writing complex Python scripts. But the major focus will be on understanding Kubernetes APIs and how to create any application that wants to talk to the API server from scratch. Of course, we have many Kubernetes client libraries that are written in Python Go, and they are very easy to actually understand and develop any application. But in order to understand how these APIs work and all, we need to understand how to write and make API calls from scratch. So this is what we are going to do. We are not going to rely on any client libraries. We are going to develop everything from scratch by writing core API calls. And coming to the prerequisites, we should have the VS Code installed along with Git Bash, because I'm going to use Git Bash profile in VS Code in order to run Linux like commands. And of course, you should have Python installed in your local machine, and this is not a mandatory because we are going to run everything inside the Kubernetes pod. And finally, you should have Kubernetes cluster like Minikube, because we are going to deploy a lot of objects. And here, this is my VS Code. So once you click on this here, you'll see the terminal tab. I've used bash as my default terminal. In your case, it should be command prompt like this. So you can select a specific profile by selecting it from the drop down. So usually I'll use git bash because I can run shell like commands here. And I also have Python installed and a Minikube cluster also installed. So if you do Minikube status, it should actually return the status of the Minikube. So what is chaos engineering? So we know that every system inevitably fails, and every system that failed requires a repair. But that doesn't imply that it is poorly constructed from the beginning. It is just that the components that make up the entire system are prone to the failure. So if we know that the components are prone to failure, how do we proceed further then? So do we just pretend that everything will go without any problem and then seem shocked when actual problem occurs, or else do we consider this truth and include this uncertainty into our engineering process? So these are the two different ways. So one, we think that everything will go without any issue, and the second thing is we understand the issues that are going to come and then we proceed further. So Netflix engineering team have chosen the second approach, that is, they know that every system will fail at some point of time. So not fail, so they are prone to fail. So what they did is in 2011 is they released a program called kube-monkey. So in order to assess their system's dependability and how they respond to sudden outages, kube-monkey, the application which Netflix developed, will purposefully deactivate some of the infrastructure component when it is applied to the infrastructure. So what it does is it basically creates outages intentionally in the infrastructure. And Netflix runs this kube-monkey intentionally on its production environment to test their system's reliability. What is chaos engineering then? So chaos engineering is an approach to identify the failures before they become outages. So by proactively testing how a system responds in case of a real failure, you can easily identify and fix those failures before they become real outages. By performing smallest possible experiments, you can measure, and once you're able to break things on purpose, you will understand how to fix them and how to build more resilient systems. So this is what chaos engineering actually does. Then what is Chaos Monkey in this case? So Chaos Monkey is a software that actually implements this chaos engineering of randomly bringing in the outages inside the infrastructure. So Chaos Monkey is a software tool that is developed by Netflix engineers to test the resiliency and recoverability of their applications when the applications or some of the instances of application are forcefully or intentionally brought down at random intervals of time. So following their migration to the cloud, basically Netflix needed a technology that could show them how the systems respond when some of the critical components of the production servers were taken down. So this is where Chaos Monkey was helpful, and Netflix basically developed this Chaos Monkey for this very specific purpose. Now, what is this kube-monkey? So we know that Chaos Monkey, it is applied at the infra level for bringing some of the nodes and all. But can we apply the same principle to the Kubernetes? So instead of bringing down Kubernetes worker nodes or anything like that, can we actually bring down Kubernetes pods randomly and test whether your application is reachable from outside or not? So this is where kube-monkey was developed. So it is actually an implementation of Netflix Chaos Monkey. So this kube-monkey is written in GoLang. So what kube-monkey actually does is it randomly deletes Kubernetes pods within a cluster. So this is as good as injecting failures in the system and then testing whether you're able to access your application or not. And this kube-monkey, just like Chaos Monkey, runs at a predefined and configurable schedule, and it targets some of the pods from a namespace, and these pods will be killed, and then we can actually test the resiliency of your complete system. And this kube-monkey will not actually terminate all the pods. So what we can do is we can explicitly opt in by specifying certain labels on all your objects, that is all your pods. So if kube-monkey detects those labels on the pods, it will actually consider terminating them in order to test the resiliency. And I'm going to show you the kube-monkey repository also and how this is implemented in some time. Now we know that we should actually take down some of the pods in order to understand how the system responds. So how do you actually delete those pods? So will you actually use kubectl commands from for deleting the pods? It is not the actual use case, because someone has to manually run these kubectl commands in order to delete the pods. And also deleting random pods is not an easier task, because you should manually select some of the pods and delete them. Of course, you can make a shell script and then read the kubectl get pod outputs, select a random thing, and then you can issue kubectl delete command to delete it. But here that's not our intention. So what we are going to do is we are going to create an application that runs within the Kubernetes environment as a Kubernetes pod in a namespace, and that pod will try to bring down other pods in the same or other namespaces. So we would actually want it to not touch our default namespaces. So what we would do is we will actually ask it to delete or randomly delete pods from a specific namespace, and this application itself will run as a Kubernetes pod instead of running it outside the Kubernetes environment. So for this, what we will do is we'll basically create a Python application, and then we call it as a Chaos Monkey application, and then deploy it as a pod. And this pod actually deletes the other pods. So for this, what it will do is it will make an API call to the API server by using the proper authentications. Again, we'll understand how this Chaos Monkey pod will get all the permissions in order to delete the other pods, and how actually API server is going to authenticate or allow the request from Chaos Monkey pod. So we'll understand all this in some time. So this is the actual the demo that we are going to look at. So we're going to create a Chaos Monkey application, deploy it as a pod, and so this pod will randomly select pods from a specific namespace that we are going to ask it, and then it deletes them. So this is the actual implementation of a kube-monkey, but here we are going to write everything from scratch using the Kubernetes API, and we are not going to touch any client libraries which are already existing. And in order to understand how this chaos monkey can actually talk to the API server, so we need to understand what are user accounts and service accounts. So we know that Kubernetes can, you can authenticate yourself to the API server in two ways. One, you can authenticate with the user accounts, and the other one is through service accounts. Basically, user accounts are for the humans, but what about the processes running inside the containers? Let's say I created a GoLang application, and that GoLang application wants to get all the namespaces in the cluster. So for Kubernetes, so this GoLang application is not a user, it is a process. So how do a process can talk to the API server? It is through service accounts. So service accounts are for the bots or any third-party applications, you can say, or some processes which runs inside the container. And so if a user has the certificate and key for the authentication, so this service account will not have it. So the service account will have a token that is created for it. So whenever I create a service account, a token will be created, and using this token, any process running inside the container can actually authenticate with the API server. And here one important thing is, so whenever a namespace is created, so there will be at least one service account that is created along with that namespace. And if you look at the service accounts in any namespace, there will be a service account called by the name default. And so if you don't specify any service account when you try to create a pod, Kubernetes will actually use this default service account that is available in that namespace. And kubelets, once it tries to create a pod, automatically mounts this service account into the pod. And as I said, every service account is bound to a token, so that actual token will be injected into the pod as a volume at this location, that is var run secrets kubernetes.io/service account. Inside this service account, so you will have the token like /token. So this is where your token will be injected. Then what we can do is, since this token is already mounted into the pod, so the processes running inside the pod can read this token, and it can authenticate with the API server. And remember, it is only the authentication part, it is not the authorization part. So having a token doesn't mean that you can do any sort of activity in the cluster. So let's say that using default account, I cannot actually delete anything in the other namespaces, because this default service account will have only limited privileges. So for this, what we would do is, so let's say I wanted to read all the cluster level resources. Then what I would do is, I would create a service account and then create a cluster role, and then bind this cluster role with the service account through cluster role binding. So in this way, I can ensure that the service account which I created will have all the cluster level privileges. Source code. Now coming to the source code, we are going to create a Python application using a lot of libraries and understand basically how to make an API call, the HTTP parameters that needed to be passed, and we'll also understand how to Dockerize this by writing a Docker file, and then we'll understand how to deploy this as a pod, and understand how to create service accounts, cluster role and cluster role bindings. And finally, we'll also create a test app in some namespace and see how this kube-monkey is going to delete some random pods from that test application. So without further ado, let's get started with the actual demo. So I've already created a directory and opened it in Visual Studio Code. So inside the directory, I have two different files. One is readme.md, so where I'll be showing various instructions that we are going to follow. And then there is this test app.yaml file, which is basically a deployment. And this image is already available in the Docker Hub. So I'm going to deploy 3 replicas of this application in the dev namespace. And here I am also exposing, so basically I'm not exposing it outside. So my main intention is not to expose it, but if you want, you can also make it as node port service. And we can try to access it from outside. So let me actually make it as a node port service here. So this is a test YAML. So the first thing that we are going to do is we are going to actually start writing the Python application. But before that, let's understand what is kube-monkey. So here this is the repository of kube-monkey from this SOPT user, and this is completely written in GoLang. So if you go through this documentation, so you would understand that it is configured to run at specific car, and you can also configure it to run on specific days. In fact, you can also blacklist some namespaces if you don't want your kube-monkey to delete pods from that namespaces. And also this kube-monkey will only delete pods. So if those pods have this label, that is kube-monkey/enable is set to enable, then only kube-monkey will kube-monkey can actually terminate it randomly. And also there are some other modes as well. You can see here all are configured through labels only. So we are not going to see anything from this repository because we are going to make everything from scratch. And also, as I said, you can actually talk to Kubernetes using kubectl command line. So if you open up a terminal, I already have my Minikube cluster up and running. I can just show the status, Minikube status. And if you want to see all the pods, you can just run kubectl get pods. So this is talking to the Kubernetes through kubectl utility, and I can use -a, so that will fetch all the pods in all the namespaces. But you can also talk to the API server programmatically. So for this, there are a lot of client libraries which are created by Kubernetes that uses the Kubernetes REST API, and all these basically reads your kubeconfig file and then take the credentials of the user from that file and authenticate with the API server. But we'll follow a different approach, that is through ServiceAccounts. But let's also understand this. So I'm going to go to the Python client library by clicking on this Python link here. And here, so this is a Python client for Kubernetes API. So for this, we need to actually install Kubernetes Python module. So I'm going to copy this command, that is pip install Kubernetes. So you also need to make sure that you have the Python 3 installed. In my case, it is already there. And as you can also see, some of the dependencies are also available within my machine. So currently it is installing Kubernetes. So once Kubernetes is installed, I can basically make calls to the Kubernetes API server. So for listing all the pods, this is a sample script. So if you see what it is doing here is, so they are importing the Kubernetes library and then loading the kubeconfig file from the local machine, and then they are calling the core API, so that can list all the pods in all the namespaces. And in the return, so they are actually iterating through the items from that response, and they are just printing the pod IP namespace and metadata. So let's actually copy this piece of code, and if you see, Python module is already installed. Let's click on new. So let's say test.py, and let's paste this particular script. So this is basically using the Kubernetes client library written in Python. So what I'm going to do is I'm going to run it by using Python and test.py. And if you see, basically it is reading the kubeconfig file from my local machine and then authenticating with the API server to fetch all the pods from all the namespaces. This is actually an easier method because we don't have to write a huge code in order to talk to the API server. And here we also need to rely on the kubeconfig file. So if you're planning to Dockerize it, what you have to do is you have to basically take your kubeconfig file from the local machine, and then you have to mount it into that pod into the same location, that is inside the .kube folder. Then this particular piece of code will work. But since we don't rely on client libraries, all I'm going to do is I'm going to just delete this. So I don't require this. So we are going to build one from the scratch. And there are also some client libraries written in Go and the other programming languages like Ruby, .NET, C, but we don't require anything as of now. So first thing that we will do is, so we are going to search for a very specific topic, that is making API calls. So let's understand if Kubernetes has a documentation on how to make API calls from pods. So here, accessing the Kubernetes API from the pods. So don't worry, I'll put everything in the README. So from here, what Kubernetes saying is accessing the API from within the pod. So you can use official client libraries, and for that we already seen the example. So what we are interested in directly accessing the REST API without relying on client libraries. So for this, what Kubernetes is saying is the recommended way to authenticate with the API server is through a service account. So we are going to create a new service account, and by default pod is associated with a service account, gets a token, and that token is actually stored in this. And if available, certificate bundle is placed into the file system of each container. Because I need to make an HTTPS call to the API server, for that I need a certificate of CA, and that is also mounted into the each pod at this particular location. And finally, the namespace information is also mounted. That is one way. So what we can actually do is, so in order to make an API call, as we already discussed, so basically we need to understand where exactly the API server is running. So what is its port number, what is its IP address. Then we can pass the authentication information to authenticate with the API server. So for this, if you see, API server is actually listening on this kubernetes.default.svc. So what is this endpoint? So basically Kubernetes, this is the name, this is actually the name of this service. This directly points to the internal API server. So without actually worrying about on what IP address your API server is running, so what we can actually do is we can use this standard URL which will be resolved to the Kubernetes internal API server. And the service account token can be found in this location. CA certificate can be found from this location. And in order to make an API call through curl, so it is curl, you need to pass the certificate information, and in the header, authorization header, we need to pass the bearer token. So that token is also mounted into the pod that you are actually wanted to make. So here kube-monkey is the pod that we are going to deploy. So that pod will get a token. Using that token, it will make an API call. And here we are making a get API call, and we are going to call /API endpoint, and this is how the response we are going to get. So this is the only required information to get started. So what we are going to do is we are going to start writing our application. So let's create a file known as app.py to start writing our Python programming. Meanwhile, let's also try to write the RBAC file, that is creating service account and all that. So what we are going to do is we are going to actually write a file called deployment.yaml file. So this deployment.yaml file is the file required to deploy our kube-monkey along with service account and cluster role binding. So first thing is we are going to do is we are going to create a service account. So for that, I'm going to search for service account. So creating service account in the new tab. So all I'm going to do is I'm going to just basically take this part. And one more thing is service account. Once you mention a service account inside the pod definition, the service account token will be automatically mounted as the volume into that pod. But if you don't want that to happen, what I can do is I can actually turn off this auto mounting service account token, but I don't require anything of that sort. So what I'm going to do is I'm going to auto mount it. So service account, I'm going to name this service account as chaos, and the namespace I'm going to use is a default. Now this is the service account by the name chaos, but this will not have permissions to delete pods from the other namespaces and all. So for this, what I'm going to do is I'm also going to create the cluster role. So that cluster role will have all the permissions or privileges to list, delete all the pods and namespaces. So for this, I'm going to take this example of role. This is role, but you can also find the cluster role here. So let's copy the cluster role. So cluster role, the name of the cluster role also I'm going to name it as chaos. API groups is double quotes because that is the core API group, and the resources I'm going to control is pods, and for the pods I'm going to get watch list, and the other privilege that I'm going to give is delete privilege, because our chaos monkey should be able to actually delete the pod as well. So this is one rule. And also what I'm going to do is I'm going to also give it permissions to read all the namespaces as well from the cluster. So it is a core API group again, and coming to the resources, it is just the namespaces, and this is API groups, that is fine. And coming to the verbs, so I don't want the delete, so I just want the get and the list, that's it. So I'll be listing all the namespaces, and also I can get the date of an individual namespace. So this is the cluster level role I have created. Now what I have to do is I have to actually bind this cluster role with the service account that we just created. So for this we are going to look for the cluster role binding. So this is the cluster role binding. So let's copy this cluster role binding object and paste it here. So let's delete the extra comment. So cluster role binding. So the name of the cluster role binding also I'm going to mark it as chaos. So kind is not a group, or kind is not basically a user. So here kind is nothing but our, so this is the subject means the end user. So here the subject would be a service account, the service account by the name chaos that we created. And coming to the cluster role, the name of the cluster role is chaos, that's it. In fact, if you also want to use the namespaces here, we can also use it. So that's it. I think the API group is not required for the service account kind, and then I can also mention the namespace here, because the namespace is inside the namespace is the default namespace, that's it. So we don't require anything. So we created the service account and then gave it all the permissions to talk to the cluster. And here what I'm going to do now is I'm going to create actual chaos monkey pod that will mount this service account. So for this I need a pod definition. If you want to deploy it as a deployment, you can also do it, but I want to deploy it as a single pod. So let's copy this information from here and then just paste it. So it is a pod. Metadata name I'm going to use as chaos only. Namespace information is not required. The container name also chaos. So this if you see here, I'm going to use this name as the Docker image name. So I'm going to use the same name here. So ports are not required because I'm not going to expose this anywhere. That's it. If you want to also use image pull policy, you can use it as always. That's it. And how do this pod uses our custom service account that we used? So what I can do is, if you go to the official Kubernetes documentation, so you would know that we can use custom service account name. So by having this parameter service account name, the service account which we just created, so here always should be capitalized. That's it. So instead of using the default service account. So this particular pod called chaos will be running my chaos monkey application, and it uses the chaos service account, so it gets a token. That token can actually do all these operations. That means using that token I can do all these operations. So my deployment file is ready. Now let's start to write our actual application. So what exactly I need to consider for writing an application? So the thing is, I'll have to make a lot of functions, that's for sure. The thing is, the first I need to get the namespace information on which this particular chaos monkey this chaos monkey can target, and at what interval. So for that I will also require the time, like let's say for every 1 minute or for every 5 minutes. So I need that interval from the user. And also let's say that my kube-monkey is itself a pod, so it should not be deleted by itself. So for that, what I'm going to do is I'm going to actually ignore it. So ignore pod, which means I have to ignore my chaos monkey pod so that it won't be accidentally deleted. Okay, that's it. So these informations I need from the user. But how do I user provide all this? So we know that in Kubernetes we have a concept known as environment variables. So using environment variables I can supply the environment variables to the containers. So all I'm going to do is I'm going to search for environment variables in order to understand how to use it. So define environment variables. If you scroll here, this is the syntax. So we are going to use this. Let's paste at the containers level environment, and there are two environment variables. So what environment variables I need to put? So let's say interval. So what is the interval? So I'm going to input let's say maybe 30. So it supports the string data type, so I'm putting 30 interval. And namespace. So in what namespace I have to actually run my target my chaos monkey operations. So let's say I wanted to target dev namespace, all the pods that are running in the dev namespaces. So these are the environment variables. So now once I deploy my pod, this application will have access to that environment variables. So how do I get all those environment variables into my application? So for this I can use Python's OS module. For this I've already given the link in the readme file. So here if you see, I have so here, so Geeks for Geeks, access environment variables in Python. Of course you can refer any number any website for this information, but here they have given it very straightforward. That's why I'm actually using it. So if you do os.envir, it will actually print all the environment variables within that environment. And also if you want to read a specific environment variable, you can just pass it as an argument here. But the important thing is I'll be using a different approach. So let's say that I'll use this os.environment.git. So let me use this. So if I use this in my application, so this is an OS module, so definitely I have to import OS module like this. So os.environment get. So what I wanted to get, because in the environment variables I'm supplying interval as the environment variable. So let's just get that environment variable like this, and let me assign it to this interval like this. os.environment is assigned to again this interval as the variable name. And since I'm going to get it as a string, I have to convert into integer because interval is an integer. But what is the problem with this approach is, let's say someone forgot to supply this environment variable. In this case this application will fail because it is actually trying to read the interval value, and if the user is not supplying anything to it, it is going to ultimately fail. So for this, what we can actually do is we can also supply some default values. So if you use something like -60 here, if you scroll to the very end of the application here, they also have something known as a default. So what is this default is, if the environment variable is not supplied, the default value will be considered. So in this case, so if the environment variable interval is not given, so it is assumed to be 60. And here namespace or let's say namespace to actually test, it is again same os.environment.get. From the environment variable we are going to get the namespace. And since namespace, I don't want to target any specific namespace if it is not provided, I'm going to just put it as none, which is a null data type in Python. Okay. And one more thing here, so ignore pod. So I don't want my own pod to be actually killed. In this case, I need to get that pod name. So if you see my deployment, so this is just a normal pod with the chaos. So if you see, chaos is the pod name, which is pretty simple to remember. In fact, I can hard code it. But what if people actually deploys with a different name? So then my hard coding information will not work. So for this, we'll use a unique approach where Kubernetes automatically injects the name of the pod as an environment variable. So without actually hard coding, so whenever a pod is deployed, its actual name is injected as an environment variable, just like what we have done here. So for this, again, Kubernetes has various tutorials. So if you search for inject pod data, so expose pod information to container. So pod information in the sense pod name, pod namespace, etc. So if you look at this here, the name, the node in which the pod is actually running, or the name of the pod, etc., can be injected as an environment variable. So what I'm going to do is I'm going to just take this information and then put it here. So what is the meaning of this is, so the name, my pod name, and I'm going to get the value from metadata. This is metadata dot name, and you can treat this as my pod name. That's it. So here, so let me turn off this syntaxing. So if you see here, the metadata.name, that is the actual pod name, is being injected as an environment variable with this name called my pod name, which means with my pod name as the environment variable, I can actually get the pod name. If the pod is a part of deployment, so the pod will get another hash. So I will also get that information from this my pod name, because the pod information itself is being injected as the environment variable. So ignore pod will always fetch the name of my pod. And also, if you want, you can also set the default to none, so that if no pod name is provided, it will actually become a null value. So all the informations that we required, we got it. And also, if you want to print, I can basically print some information like info. So chaos pod name is, so I can actually use syntax like this. So this will actually print chaos pod name. So sorry for the typo, so it is chaos. Pod name is this. So pod name will be printed at the beginning. It's just in order to see in the logs. So now what we are going to do is, so if the user doesn't input any namespace, I don't want this program to actually run. I want it to actually fail. So what I'm going to do, I'm going to write an if statement. So if namespace to test, okay. So if namespace is provided, that namespace will be saved into this variable, otherwise none will be saved. So if that is none, that is no namespace is actually provided by the user, so then I want to print some error type of log saying please provide namespace to test, and then let's close this, and then I wanted to actually exit, so that whenever no namespace is provided, this program will actually exit. And then else what I'm going to do is let's say the basically someone provided the namespace, then what I'll say is running test on the namespace this. So this is a variable, so on the namespace it is a fixed string, and this namespace to test at an interval and the interval. So this is going to actually print the information like this. That is, if no namespace is provided, it is going to print please provide a namespace to test, and it will exit. Otherwise, if namespace is provided, it is going to print info running tests on the namespace x at an interval of y. So that is just to show you that in the log, so that people will easily understand. So now we get the information like the interval and namespace to test. So now let's start writing the API calls. For that, as we already discussed, we need to get the the service account token and the CA certificate location, and the API server URL is this, which we already know. So let's try to get that information. So I would require the token, I would require the CA cert, and then if you see here, we need to actually write this header value. So let's copy this, let's frame this later. So header is this, so I'm going to use header as the variable, and then your input should be the value of the header should be authorization bearer followed by this actual token. So that token is this token, which we will see. If you want, you can also use the capital letters like this, it's up to us. And then the token, so token is actually injected into the location. So this is the location slash token. So how do I read this and then basically store it back to your token variable? So it is not like we will do cat and then get the value and then store it back, because this is a Linux command, this won't work. So for this, what I'm going to do is I'm going to use a subprocess module in Linux, or a subprocess library. So the links are also given, I think, here. If it is not here, so let me check again in the readme whether I've given or not. So I've not given, so let's search for subprocess in Python, and then you can take anything like subprocess management. So here it has a lot of commands like subprocess.run to run a particular Linux based command inside your Python script. So this is what basically we use subprocess for. So you can call you can execute any command. So if you see here, so they are running this subprocess.run ls-l. So this usually means listing the file system contents. So for instead of running, I also need to get the output, because I want to read the data from that particular file location. So for this, there is a separate API call called check output. So this check output, so what we will do is subprocess.checkOutput, arguments means the actual command, and then shell, we want to run it in shell, so shell equal to true. And here universal lines is also, we need to make it as true. So we can just copy this whole command and let's start to modify it in some location. So let's form this. So subprocess.checkout, as an argument, what we will do is we will actually within the double quotes cat this particular token value. So let's cat this token, and then we don't require anything like this, anything of this. So since this is a shell command, so I will make shell as true. So if you can refer the documentation for all the flags and all, and here universal lines also I would like to make it as true, otherwise you will get it in a different format, and just delete the rest of the lines. So here subprocess dot check output, that is the output of cat, and this file name will be stored, and shell equal to true, new lines equal to true. I'm going to cut this and put it here. So now since this is a subprocess module, I should also import subprocess, and then here subprocess dot check output, the output will be the token value inside the pod, and it is stored back to the token. And CAssert, we don't have to actually read the content, we just have to pass the location to the API call. So for this, what we will do is we'll just CAssert location, it is ServiceAccounts / CAssert. So what we'll do is we'll take this service account location and then just replace it here /CAssert, and then actually double quote it. So this is the location of your CAssert. And now how do you form the header? So header, we can actually send it as a dictionary element. So for this, what we will do is we'll convert into a dictionary object. So authorization, I can put it as single quotes, and bearer should also be quoted. So make sure that bearer space quote you have to input, because authorization should be equal to bearer space the actual token. So the actual token is this. So these are all Linux based commands. So in Python you can basically send it like this. So it is bearer and token, that's it. And then here, so this is a string object, sorry, this is not required, that's it. So it is header, authorization, bearer plus token, that's it. And also we should enter the accept, that is what the server will actually accept. So this is again one more header. So the server should actually accept the application /JSON, that's it. We don't require anything more than this header. So now we formulated all the required parameters to make an API call. Now let's start to create some functions. So the first function I'm going to actually use is namespace function. So let's say get all namespaces. So this is the function I wanted to make, and I will start writing the def keyword and the name of the function. So get namespaces, that's it. It is a simple function, and let's pass it so that we'll start writing the logic. So we will be making an API call to get all the namespaces, but how do that API calls looks like? What is the endpoint? So in order to understand the endpoints, so endpoint in the sense, what is the URL? So which URL you're going to use, which URL you will use to call the API server along with proper endpoint details to get the list of namespaces. So first understand how to get the namespaces in Kubernetes using kubectl utility. So it is kubectl get namespace. So kubectl get namespace, it will give you this, but you will never understand what is actually going behind in this scenes. So for this, what we will do is we'll use kubectl get ns and use the verbose level to 7. So if you use the verbose level to 7, now you can easily see what exactly is happening behind the scenes. You will understand that the config file is loaded, and this is the actual API call. So let's just copy the API call and just copy it here. So here, so the first part is HTTPS, and the IPN port, this becomes the API server details, and we are more interested in this /API/v1/namespaces, and limit I don't require to pass any limit. So this is the actual endpoint /API v1 namespaces, that is API v1 is the version, namespaces, this is the API that I have to use. And also if you go back to the documentation, the API server URL is actually this, so I don't require to pass the IPN port. In fact, I can easily replace it with this information. So now this becomes the actual the API server endpoint followed by the namespaces endpoint. And if you want, since basically I'm running the pod in the same namespace, I can in fact delete the default.svc. So HTTPS Kubernetes API v1 namespaces is the actual URL. So what I'm going to do is I'm just going to use this as the URL, that is HTTPS, and then just double quote it. Now how do I make API calls in Kubernetes, in Python? So for this I need to use the request module, and the link to that request module is also given here, Python module request. So you can refer from the W3 schools. So in order to get, that is, if I have to get, I will use get API call. If I have to delete, I have to use the delete API call or the HTTP method. So for this it is import request, that is the request module. Let's first import it, and then in order to make an API call, it is request.get and the actual URL. So let's just copy this and try to build our API call from here. So X means it is actually the response, so let's call it as a response. Response is equal to request.get, and this is the actual URL, so which we already stored with a variable name called URL. But this is a plain API call. I need to actually pass the authentication information, that is the the CA certificate and also the token. So for this, I'm going to use this get to see the complete get method details, and here I can use the URL, send some parameters and some arguments also. So here in the arguments I can pass the verify. So verify is it is a TLS certificate, that is verify. And not to pass the authentication, I think you have the header. Yes, header is equal to, so headers we have, and verify. So header is for the header information, verify is for the CA certificate. So what we will do is, so headers equal to, so what is the actual header? If you remember, we actually define header, let me use a capital letter. So header is actual header, or let's say headers. Header is equal to headers, so this will pass the headers, and verify is equal to CA certificate, the location of the CA certificate. So this should actually give me this should actually get the request sent to the API server without any issue. And here response is the output, and basically I can also print the response in the JSON format, because response will be I can just say response dot in the JSON format if I require JSON, and then close it, and comma if you also require the response status code in the HTTP. In the response library you also have the request library, you also have the option to get the status code like this. Now the whole thing is prone to actually fail sometimes if the URLs are not properly given. So all I'm going to do is I'm going to put the entire thing in try and except block. So except exception as E, so the entire exception is stored in this E. Then I'll say print So this would be an error in case my request is not successful due to any issue. So I would say exception raised while getting namespaces, and the exception result is stored in E. So let's say E like this here. And if you want, you can also exit one in case if you're not able to fetch the namespaces, because basically that's the first API call that we are trying to make. And in order to just test whether everything is working properly or not, so what I'm going to do is I'm going to just call this function outside. So whenever I call this function, so I need to get the response printed. So directly it won't run because the tokens and all are mounted into the pod. So first we need to deploy this pod. So for this I need to basically dockerize this application. So for this, let's start to write the docker file, and let's proceed from there. So docker file, I have to use the Python docker image. So docker hub, so let's say Python, let's use Python 3.9 or 3.10, anything. So let's click on tag. So let's take the Python 3.9 slim bullseye. It is 45 MB, or 3.9 slim, it is also 45. So let's take this. So let's copy this and start to write. So I'll use this as from instruction 3.9 slim, and then here I need to install some modules, that is request module. So for this, what I would do is I would actually pip install request module, but since I don't want to cache all this, I can also use no cache direct. So this is another flag. Even if you don't use that's fine. So I'm setting the working directory as /app, and then let's copy our app.py from the current location into that /app, and then set the CMD or the entry point. It is up to you. So I'm going to write Python comma app.py. So this is an executable form, which is pretty good. So this is the actual docker file to dockerize my application. And if you see, I actually don't have Docker installed in my system. So you can see that even though Docker CLI is available, Docker daemon is not running in my local system, but Minikube itself has Docker internally running. So what if I can connect my Docker client with the daemon running inside the Minikube? So Docker client, it is easy to install in your local machine, and in order to connect it to Minikube Docker environment, so I can, if you just do Minikube Docker env, it will just give you this these set of the environment variables. So using an environment variable called docker host, I can actually connect to the Docker daemon running inside Minikube. So for this, simply run this command. So this will actually export all the environment variables into your local machine. Now your local client, that is Docker CLI, can actually talk to the daemon which is running inside the Minikube. So now I also have the Docker daemon. So let's build this. So docker build -t. So I'm going to name as my account name /chaosmonkey 1.0, and then I'm going to push it to a Docker Hub. So let's do Docker images to see the this size. So it is Chaos Monkey, it is 134 MB. That's fine. So let's push it. So Chaos Monkey 1.0. So it is pushed. Now if you look at the deployment.yaml file, so we are actually deploying the chaos monkey 1.0, the same image, and our app is pretty simple as of now, because it is nothing but it is going to list all the namespaces in the form of JSON. That's it. So what we'll do is we'll actually run our deployment file, that is deploy or chaos monkey. So if you see service account, cluster binding are actually created. So kubectl get pods. So it is completed. Basically it is completed because we are not running in the infinite loop. So the pod will actually print the namespaces and it will exit. If you look at the logs of this chaos pod, you can see that the chaos pod name is chaos because it is actually given in the code. So we are actually printing it. That's why it is printing. Now running tests on the namespace dev at an interval of 30. So even though we gave in the configuration to test the dev namespace, we are actually not sure whether dev namespace is available or not. So what we'll do is, in the next step, we'll fail this particular program if the namespace that is requested is not available within the cluster. And also you can see that we are getting this good JSON response, and the response status code is 200. It is because that our API calls are successful. So if you make even a small mistake, your API calls will actually fail. Now in order to understand, see, it is continuously restarting. So what we'll do is, first we'll delete it. So let's undeploy this particular chaos monkey and let's start building the rest of the code. So now that we understood how to get namespaces as JSON, so basically the response which we are getting is in the form of JSON. So all I'm going to do is I'm just going to name this function as JSON, and you can also, so let's name it here. You can also get the information directly from the pod log. So what we'll do is we will try to rebuild this application again, and I'm going to show you the exact JSON response from within the pod. So for this I'm going to write a small shell script called rebuild redeploy, because I don't want to run all the commands one after the other again and again. So let's create a small shell script that will delete the existing kube-monkey deployment. So it's deployment.yaml, and then it is going to build the actual Docker image like this. So Docker build, it is going to build with the same tag and it is going to push it. And after that, what I'm going to do is I am going to apply the new YAML file. So here, so let's use sh rebuild and redeploy. So our existing deployment will be uninstalled and then new image will be pushed. So all we did is we just changed this function name, and we are rebuilding the image and we are pushing it to Docker Hub again. So now what we'll do is since it is already installed, so let's get the pods in the default namespace. So it is chaos and it is in the completed states. Let's get the logs. You can see that this entire thing is a JSON and the kind is namespace list, because we are getting everything in the form of the JSON output, and we are going to get the list of namespaces. And you can also see that running tests on the namespace dev at an interval of 30. So how do you parse this information to extract only the namespaces names? So for this, you don't have to copy this entire output from here, because if you know the kubectl commands in order to get the output in the JSON format, so it is kubectl get namespace -o in the JSON. So this is exactly the output that you are seeing from within the pod logs. So I can actually copy this and go to any JSON parser website. So you can choose anything, and then I'm going to paste it here. So on the right hand side you will see the parsed JSON output, and in the option you can actually select various other options. And if you see here, we have API version is v1 item. So items here indicates the list of namespaces, and if you minimize this you can see that the number is 4 because there are 4 items as a list. So each list item is itself information about a specific namespace. And if you want to verify how many namespaces are available, I can actually use kubectl get namespace. So there are 4 of them, all are the standard namespaces. And how do I get the information about or the name of each namespace is from the items. I'm going to iterate through each and every element, and I'm going to get the metadata dot name. So metadata dot name gives me the namespace name. And what we'll do in our actual program is, so here we are reading the namespace to test from the environment variables. So if the environment variable is none, so if it is not defined, of course we are exiting. So what if someone through the deployment .yaml gives a namespace called prod, and my program checks will pass because the namespace is not none, but still that namespace prod is not exactly available in my cluster. So in this case I need to fail the program here. So for this I can read that prod namespace from the environment variable, and then since I already have the namespaces as JSON output, I can easily check, and then I can fail if the prod namespace is not available in the cluster. So here instead of comparing the prod namespace with the namespaces as the JSON output, what I will do is I'll show you another method where we will take this JSON output and then extract only the namespaces names and then store them as a list. So for this I'm going to create a new function called get all namespaces as list, because list is easy to compare. So the function name I'm going to use is get namespaces as list, and it won't take any argument. And here what I'll do is so namespaces I'm going to define as an empty list because I don't have anything yet. So here from this API I'm going to read the complete JSON output, and then I'll store it back to a variable known as, let's assume, data. So data is equal to get namespaces as JSON. So this function is actually not returning anything, so we are going to disable these print statements, and then from here we will just return the response.json. So whenever I call this function, that is this function, it is going to return the JSON output, and that I'm going to store it in the data. So now I can read that JSON, and then I can extract that names. So for this what we will do is so we'll iterate through each and every element. So for this I'm going to make an initial check, that is if the data is available, that is if the JSON response has some data, then only I'm going to actually enter inside. And then how do I parse the information, because this data is a JSON, and if you remember, so here this complete output we are calling it as data. From the data I'm going to iterate through each and every element of this items list. So I'm going to go to the program for item in data of items, because this is a JSON. So data.items, so data.items means this whole thing, that is the whole dictionary. I'm iterating through each and every individual element of that dictionary, that list. So this each item here represents a namespace data. So item is namespace data, so that there are 4 items. So how do I extract each and every element, each and every namespace information? So metadata name. So each item is a JSON. So here this particular part is the first item of the list. So in that I am extracting the metadata name. So this will be the name of the first namespace, and I'm going to store it back to the namespaces list, that is namespaces.append, and then I'm just going to close this. So the first namespace name will be appended to the list that we created, and it is going to iterate through all the items in that items list. So this is the namespaces. So once the iteration is completed, basically I can try printing it. So print, let's say, namespaces. So this is the list element. So this is the empty list, but once it is iterated, it is going to get populated with all the namespaces as the list. So for this, I don't want to call this above function for testing. I'm going to call this function, that is get namespaces as the list. So now this function will call the JSON function, get the output, and then it is going to just iterate. Of course we are going to further improvise this, but let's try to rebuild and then redeploy this using that shell script. So first we'll uninstall the existing deployment and then build the new image, push it, and then redeploy the new image. So let's get the pods now. So the pods is in the container creation state, it is completed. Let's get the logs, kubectl logs chaos. That's it. So now you can see chaos pod name is chaos itself, running tests on namespace prod at an interval of 30, and then these are the existing namespaces. But unfortunately, since we are running on prod namespace, but prod namespace is not available in the cluster, so we are going to fail this particular program at that point. But here, this function is not completed yet, because so we will get a lot of issues in the real time. So let's put everything in the try block, so that when we get any error, we can actually catch that exception. So here in the except block, I can say except exception as E. So print error exception raised while getting the namespaces. That's it. So if you want to use any other error messages, you can of course do that. And if you want, you can also exit in case if the namespaces are not able to be fetched from the cluster. So this is get namespaces as list. So what we'll do is, as the initial step, we are going to fail if the requested namespace is not available in the cluster. So for this, I'm going to start writing the main function of the Python, that is if __ name is equal to main. That is, this program will only run if you run it as the main program. If you try to import this particular file as a module, it won't work. So if condition, so first thing that I'm going to do here is, so I'm going to get the namespaces is equal to, I'm going to call the namespaces as the list function. So it is going to return me the list, and then that list is again stored back to the namespaces. But here if you see, this function is exactly not returning anything. So let's comment out this print function. This is not required. Let's ask this particular program to return the namespaces. Okay, so this return namespaces will return the list, and again I'm storing it back to the namespaces list as before. So this is pretty straightforward. And then what we'll do now is, since now this namespaces will have the list, so what we will do is, if the namespace to test, because that is the one which we are reading from the environment variable, that is the one which user requested, if not in namespaces, that is the requested namespace is not in the namespaces in the cluster, so we are going to error out, saying that error requested namespace, that is namespace to test, namespace to to test is not created or not available in the cluster. So we can error out like this. That's it. So if the namespace is not available, so we'll error out and exit 1. So this is the first check again, that is if the requested namespace is not available, we are going to error out. That's it. So again what we'll do is, in the deployment again we have the prod namespace which is not available in the cluster. So let's rebuild this application and see whether your deployment will your pod will fail because the requested namespace is not available. So let's uninstall, rebuild the application, and then push it back to the Docker Hub and then deploy it again. So get the pods, it is in the pod creation state, and error as we expected. And if you see the logs, there it is, requested namespace prod is not available in the cluster because it is not yet created. Okay, so this is going to error out. So what we'll do now is, before proceeding further, so I'm going to change this to dev namespace so that the kube-monkey will actually try to delete some pods in the dev namespace. At the same time, I have this test YAML. So this test YAML is basically deploying an application with 3 replicas, that too in the dev namespace. And also there is this service object. So kubectl create namespace dev, and then let's apply this. So kubectl apply -f test YAML. So this is going to deploy everything in the dev namespace. Let's get the pods and services in the dev namespace. Yes, so it is up and running. So let's close this file now. So our initial checks are completed. So what we'll do now is, since we are testing on the dev namespace, so we will select a random pod from the dev namespace and then we will try to delete this. So for this we need to again write some functions for getting the pods. So get pods from a namespace. So this is the function that we are going to actually write, because before deleting we need to have the information about the pod. So here I'm writing the function get pods from namespace as JSON, because we know that we are going to get the output in the JSON format, and as an input I'm going to pass the namespace information. But what is the API call that I need to make? So let's say I wanted to get the pods from the dev namespace. So I'll use verbose level to 7. So here I can see this is the endpoint API v1 namespaces namespace name /pod. So let's copy this and then just paste it here. So as a URL I should have the Kubernetes endpoint URL, which we already know. So https kubernetes / so here I'm going to paste the same thing, https kubernetes / API v1 namespaces followed by the namespace name and then followed by the actual pod. So this one, so what I'll do is I'll try to just break this so that it is easier to understand. So up to /namespaces is a fixed string, and then just use add to add the string, that is the namespace, and again add the fixed string, that is /pods. So here this entire URL will be dynamic. So this namespace which we are actually passing to this function will be replaced with the replaced within the URL, and this will be a proper URL. And again, so as already discussed, we are going to use response is equal to request.get URL headers verify, and we are going to return the response in the JSON. That's it. So it's the same piece of logic, and here the response again will be in the form of JSON. You can also verify that by running it manually, that is kubectl get pods from the dev namespace output in the JSON format like this. And then I can actually copy this whole thing copy this whole thing and then actually copy it in the JSON parser site. So again, it's an items list. Here each item again will be the pod, information about the pod similar to the namespaces. And if you try to minimize this, you can see the actual count, which is 3. 3 means here there are 3 pods in the dev namespace. So you can see the name in the metadata, the namespace in which it is deployed, the spec, that is the containers information, and then the container port. If you scroll down, you'll have the status. So in the status, you can see the status, container status. So if there are n number of containers, you can see the container ready, started status of individual containers of that pod, and overall pod face, pod IP. In fact, if you want the node name, that is also available. So I can actually parse any information of the pod from the JSON. So from here, since I'm going to get the response as the JSON, so let's keep it like this. But as we already know, let's put it in the try and exception, so that your exceptions are actually captured. So printf error exception raised while getting pods from the namespaces, and then let's close it. If you want, you can also exit with 1. So since this is giving the pods from the namespace as JSON, if I want to compare it with a specific pod, it will be very difficult for me. So I'm going to write another function, get pods from a namespace as list, where I'll store all the pods information as a list element. So that's the first thing that I'm going to do. So for this, again, we are going to use the same process, that is define get pods from namespace as a list, and then I'm going to pass the namespace information. So I'm going to define an empty pods list, and then data is equal to, I'm going to call this function get pods on the namespace as JSON, and I'm going to pass the namespace information. So if I have to get all the pods from the namespace dev, so here I'll call this function, that is list function, which will in turn call the JSON function to get the JSON response. And here, since the data is a JSON or a dictionary in case of Python, so what I can actually do is I can easily parse that information. So information about the pods. So for this, what I'll do is, so if data, so in case if JSON response is at least available, I can actually go to the next line. So for item, again it's the same thing. So for item in data of items, because data itself is a complete JSON response, and here I'm going to go to this data, and this is a list element. So I'm going to iterate through each and every list element, and we know that each list element is again then information about the pod. I can get the name from metadata name, the information about each pod. So for that, so item and then metadata and then the name. So this is the pod name. So I'm going to store it back to the pods. So pods dot append each name of the pod. That's it. So this should actually give me the pod names. So let's print it for time being. So print f maybe info, something like this, pod names. So I'm going to actually pass the list of pods here like this. So make sure that you're using proper syntax. So info pod names, so I'm going to get the pod names printed here, and this whole thing, in fact, I can put it in the try block, just indent the whole piece of code, and then in the exception as e, so print error, and then try to exit if it is required. So here I'm going to print the pod names. In the earlier function, we were actually printing the namespaces. Let's also print the namespaces here itself. So we'll have both namespaces and the pod as list printed. So in the main function, so if the pass is if the namespace check is successful, in the else block, maybe in the else, what we can do is we can actually call the get pod from the namespace as the list function, and let's input the namespace. Let's pass the namespace. What namespace? You can get that from here, namespace to test, that is requested by the actual user. So let's save it and again rebuild this particular piece of code. And also, if you want, you can also input only the pods which are in the running state into that list, because some pods will be in the failed state or crash loop backoff, so you might not require those pods. In that case, you can have additional checks, that is you can parse the container status of all the pods and then only add those pods where all the containers are in the running state. Since that is a little bit complex, I'm just avoiding that for now. So a pod is deployed. Let's see the pod which is crash loop, because let's try to see the logs why it is crash loop. So it says pod names. Yeah, see, if you see, there are 3 pods, all those names are listed, and this is crash loop because our pod got deleted. So it is crash loop, restarting so many times. So that's fine. So now what we'll do is if you want to get this information in an infinite loop, so I can put this under while true, and let's call this function and give it a delay, that is time.sleep. And if you remember, we are also taking the interval, that is the delay. So time.sleep interval. So if the interval is 30, basically our function will be called every 30 seconds because it is in the infinite while loop. So we should also import the time library, and here at every interval, we are going to actually call this get pods from the namespace as list function. And in the deployment, let's make the interval to be 10 to get more responses, and let's actually try to rebuild and redeploy. So our existing deployment is uninstalled, new image is built, and then the pod will be deployed. So get pods in the running state. Since this is an infinite loop, you're going to basically get the responses every 10 seconds. So let's check the status of pod. It is in the running state, but it is not giving the logs in the real time. So what I will do is I'll exec into the pod, that is chaos pod, and then try to manually run this particular program. So already we have this app.py file, so just run python app.py. You can see that now we are getting the response, that is the namespaces are dev, default, and 3 more, and these are the pod names. And if you see, we got one more response, that is pod names after 10 seconds, which means there is some issue with the cluster because I'm running on Minikube. Maybe this particular program is taking all the CPU and memory. So what we'll do now is since we now have the information about the pods, so let's try to also make a function to delete the pod, And then in the next step, let's try to randomly select a pod and then pass it to the delete function to get it deleted. So let's write a function called delete a pod from the namespace, and then define delete pod from the namespace, and then we should actually give the namespace information and what is the API call, so what is the URL. So that's the important thing. So let's try to find it out by manual kubectl command. So kubectl delete pod, let's say delete pod nginx, and then let's try to delete it from the dev namespace, and let's use the verbose level 7. Since that pod exactly is this is not available in the cluster, but all I'm interested is in getting the URL. So let's copy this URL and then just paste it here. So here API v1 namespaces, the actual namespace name /pod followed by the name of the pod. So this is the actual URL. So what we'll do is we'll try to copy the URL till the Kubernetes part from the previous function. So here / API v1 namespaces. So this is a fixed string plus the actual namespace. So don't forget / here. Actual namespace is the namespace, and again plus within the brackets it is pods, and again / and actual pod name, which is we need to pass. So let's delete the next line. So here after the namespace you also need to pass the pod name to this function, then only a particular pod. So this pod name is read, it is used here, this namespace is used here, and this is the API call. And since this is a delete request, so instead of request.get, so we would be using request.delete, because this is a delete call. So response is equal to request.delete URL headers and verify. And since we don't require to return anything, because we are actually deleting it. In fact, if you want, you can return the status code. If it is 200, then the deletion is successful. So if you want, you can use if condition and then monitor the response status code. So what we'll do is again put it back in the try exception block to manage the exception handling. Accept exception as E, and then print error you can say while deleting pod from namespace, and error code also I can actually print, that is E, because we are capturing the error as E. Let's close the bracket. So this is the delete function, which is pretty easy function. All we need is a proper namespace and the pod name and a proper URL to call the delete function. So this is fine till now. Okay, so here we are getting we have created all the functions like fetching the namespace, fetching the pod names, fetching the namespace as list, and finally we created a function to actually delete a pod from the namespace. So now what I'll do is I'll create a function called select random pod, maybe from a namespace. Okay, so here we are going to randomly select a pod. Also for this, if you remember, we also have this get pod from namespace as list function, which will actually return the list of pods. So here in fact we are not returning anything. So what we'll do is we'll also try to return the pods information, which is a list. So let's call this function, which will return the list of pods, and then store it back to the pod. So this pods will have the list of pods in a particular namespace. In our case, if you are testing the namespace to test, that namespace information has to be passed. That is, So this namespace should be namespace to test, and this one should also namespace to test. So that information is sent to this. So in fact, if you are using namespace here, I can also use namespace here. So whatever namespace that I pass here, so will be taken here, and you're going to get the pod as a list from that namespace. So here this pods is a list. So how do I get the random? So for that I can use random library. So first let's import it. So import random, and then from there, from that library, so I can actually select the random choice, use the random choice method, and I will pass the random, and then store that random pod name to a variable called random pod. So random pod is equal to random dot choice. So if pod is a list of, let's say, 10 pod names, so it will randomly select a particular pod name. So that pod name will be stored again back to that random pod. So here this random pod, I can actually pass that pod name to this delete pod function to actually get it deleted. But before that, let's try to print the random pod, because I just wanted to know which random pod it is selecting. So information random pod name is, within this quotations, random pod. That's it. So this should actually print the random pod name. And here get pod from the namespace as list, we are calling. So this is not required for now, because anyways it is being called here. So let's call this function select random pod from namespace, and as a namespace, so I'm passing the namespace to test, which is a variable, environment variable that we read from the user. So that namespace name is sent to this namespace. Again that namespace will be sent to this namespace. So let's again dockerize this and see the random pods. Rebuild and redeploy. Since my minikube cluster is low on resources, maybe I'm not getting kubectl log output. But what I can do is I can exec into the pod and I can manually run that application. Okay, so exec into the pod and then python app.py. So let's run that program again. So here if you see random pod, it has selected. This is the name of the pod from that particular namespace. So as you see, it is randomly selecting a pod. So our logic is working. So let's rebuild the let's continue with the logic again. So I'm going to delete this printing function since I now have the random pod name. So I'm going to send it to delete pod from the namespace function. So delete pod from the namespace function, it expects two variables, two arguments. One is the namespace followed by the pod name. So the namespace is namespace to test, because that is user defined, and then the pod name is the random pod name. So that's how the functions work. So I am passing these two arguments, and once I pass it, so in fact I can put it in the try and exception block as well, because this is pretty much needed. Print error while deleting the pod from the namespace. That's the error message. So delete pod from the namespace. That's it. So here I can say I can write some functions, print statements here. So print let's say warn deleting the pod what is the name of the pod? It is the random pod. From the namespace, so I'm just warning the user in the logs that deleting the pod X from that namespace, and after this calling this delete function, I can say that warn deleted the pod. Of course there are additional checks are needed, because immediately after issuing the delete command the pod may not be deleted. So you need to make sure that you wait for some time until it is deleted, because we are not forced deleting it. So that's it. So here we are deleting the pod, and also we manage the exception here. And now what we'll do is, so select random pod from namespace and namespace to test. We are calling this function every 10 seconds. So that will actually select a pod, random pod, and send it to the delete function to actually delete it. So that's it. Our program is almost ready. I think we don't have to do anything for now. Let's rebuild and redeploy it again. So unfortunately the logs are not coming due to the memory issue, I think. So let's redeploy it again. And I'll also open another tab, and I'll select git bash profile. So in the next one, all I'm going to do is I'm going to get the pods in the dev namespace and also watch it. So if you see, there is one pod that is being deleted, because if I exec into the pod and just try to run that particular program, you can see that basically our kube-monkey is deleting a pod from the specific namespace dev. And in the next console, if you see, so there is already one more pod that is being created to replace the deleted pod, because our deployment is our pod is a part of deployment of 3 replicas. And if you see the other tab, so this kube-monkey keeps on deleting a random pod from the list of pods in the dev namespace, and this will continue every 10 seconds, because we have configured that in the deployment .yaml file. Of course this is not a completely ready kube-monkey program, because so here we are not considering the proper status of the pods, because if you go to the other terminal and see, the kube-monkey is actually detecting the lots of pods from the dev namespace. So here we only have 3 pods or less than 3 pods. Those should be in the running state, but here this logic basically detects any pod which is available in the cluster, irrespective of the status of the containers. So that check you need to manage it, so that the list of pods should always be the pods in the running state. So all I'm going to do now is exit from this application, and let's stop this kube-monkey application by uninstalling the deployment. So this is about the kube-monkey. So this is pretty simple. All we did is we created a deployment of kube-monkey, and then we passed the pod name. Yes, so one thing which we missed is, so what if the kube-monkey deletes the own pod name? So for this we need to have an additional check here. So before sending that pod name to the delete function, so here we are sending it to the delete function. So what we need to do is we need to actually check if the random pod, so in, that is ignore pod, because the ignore pod is nothing but the name of the kube-monkey pod or chaos monkey pod. If that random pod which we are selecting is the ignore pod, so what we need to do is we need to print a statement that is info so ignoring kube-monkey pod, because we should not actually delete this. And what we'll do is we'll simply return to the caller by using return statement, because we don't want to do anything once the randomly selected pod is the kube-monkey pod itself. So other than that it should work fine. So you can rebuild the application and redeploy. It is going to work the same way as before. So here one thing which we did is we understood how to actually work with the request API, how to parse this JSON, how to get the API calls, so without relying on client library. So that's the thing that we seen throughout this video. And here since kube-monkey is actually deleting the random pods from the dev namespace, so we can actually see whether we are able to access this connected application in the dev namespace, even though the kube-monkey is deleting it. So for this I can get all the pods and services in the dev namespace. So here the connectivity service is running on node port on 31456, and I'll get the minikube IP. In your case you should get the IP of your master node or the external IP of this particular service. So I'll use the IP of the cluster, that is minikube cluster, followed by 31456, which is the node port of the connected city application. So let's keep refreshing this page. So you can see that my application is still running even though some of the pods are being deleted, because the deleted pods are automatically replaced by the newer pods by the deployment controller. And I'm only deleting one pod every 10 seconds. So within 10 seconds, if the new pod takes the place of the old pod, my application is still accessible all the time. So that's it for this video, and I'm going to push all the complete source code into the GitHub, and I'll share the link in the description below. Thank you, and I'll see you in the next one.